This is the world's first television ever invented. Inside it sits a rotating disc. 30 spiral small holes are arranged across the disc. As the disc spins, these holes pass through a narrow window one by one. When the disc spins at high speed, we see continuous scanning lines sweeping past. Light travels through the window and tiny holes, then strikes a photoelectric tube at the rear. Made of special light-sensitive materials, it generates electric current under light exposure and measures changes in light brightness. These light variations are converted into electric signals, which are transmitted via radio waves or telephone lines to the receiving display device. The incoming signals are amplified and sent to a special light bulb. The bulb adjusts its brightness according to the electric signals. Behind this bulb is another synchronized rotating disc. As the disc rotates, light of varying brightness projects onto the screen. A single dim spot cannot form a complete image, yet once the disc speeds up, continuous streaks of light fill the entire frame, covering every corner of the display. Together they merge into one complete picture. This early TV had extremely low resolution, only 5 frames per second, resulting in choppy playback. Still, it marked the most crucial first step for video technology. However, this mechanical television only showed black and white. To create color images, inventor John Baird divided the disc holes into 3 groups, each fitted with red, green, and blue color filters. With this design, as the disc spun rapidly, 3 sets of colored scanning lines appeared in sequence. The receiving display used the exact same design, with its disc also split into RGB filter sections. When the red filter rotated into place, red signals controlled the bulb's brightness. The same principle applied. As green and blue filters took their turns, corresponding color signals adjusted the light output. In this way, red, green, and blue light projected onto the screen in rapid succession. At a sufficient rotation speed, the 3 primary colors swept across the frame instantly. The human eye retains visual information briefly, blending the rapid color flashes together naturally. This created the first primitive color television image. Back in 1928, John Baird demonstrated this mechanical color TV in public, astonishing audiences worldwide. Even so, mechanical drive systems had major limitations, restricting practical daily use greatly. How would scientists break through this bottleneck? As early as 1857, 2 German scientists conducted a landmark experiment. They sealed 2 metal electrodes inside a glass tube and pumped out most of the internal air. After applying electric current to the electrodes, they witnessed an incredible phenomenon. The entire glass tube began to glow. The more air they removed from the tube, the more concentrated the luminous beam became. When they held up a magnet nearby, the glowing ray shifted with magnetic force. Further research revealed the principle. Electric current released electrons from the cathode terminal. Upon colliding with the glass tube's inner wall, these electrons released energy in the form of light. Later, German physicist Ferdinand Braun built upon this discovery and invented the world's first cathode ray tube. Fitted inside the glass tube were horizontal and vertical electromagnetic coils. These magnets precisely deflected the internal electron beam, drawing detailed patterns on the display screen. It also adjusted beam brightness via electric signals, producing far sharper and clearer images. Fast forward to the year 1931. Russian-American engineer Vladimir Zworykin developed the iconoscope based on cathode ray tube technology, essentially creating the first electronic video camera. Light enters through the camera lens, focusing onto a special photoelectric target plate. The plate's back was coated with thin silver film, while its front held millions of microscopic light-sensitive particles. When external light hit the photoelectric plate, light-sensitive particles emitted electrons and lost electric charge. The brighter the light, the more electrons were released. This formed natural light and shadow contrast. Dark areas retained electric charge, while bright areas became electrically neutral. An internal electron gun scanned the plate line by line. When the electron beam struck charged regions, electrons bounced back and hit internal sensors. Sensors converted optical differences into electric signals, which were then output and transmitted for further processing and broadcasting. Building on electronic cathode ray technology, CRT televisions were officially invented, the bulky big back TVs we all remember.